Hello, friends. Welcome to Learning Nails and Aesthetics. We are continuing Chapter 6 in the Milady Foundations book, Health and Public Safety, Chemistry and Chemical Safety. Transportation. The first time you enter the beauty supply store as a licensed professional, it's exciting. Here's an entire store filled with the tools of your trade, and now you're allowed to actually purchase them. It's important that as you shop, you pay attention to product labels. Some may list warnings that will affect how you transport them. For example, if a label says, "Do not store at temperatures above 78 degrees Fahrenheit," or "Avoid direct sunlight," you know that it is not safe to transport this product in your trunk or to let it sit in the car on a hot summer day. In addition, regardless of the temperature outside, a bottle sitting on the back seat with the sun beating through the window could become hot enough to ignite. Another consideration when transporting chemicals is products that are incompatible, meaning that they should not be mixed or even stored near each other. For example, hydrogen peroxide is a common chemical in a hair developer, oxidizer. However, when it is mixed with bleach, it creates chlorine gas, which can be deadly. With this in mind, driving with developer and bleach rolling around in the back seat might not be the best idea. All chemicals should be transported upright and in their original containers, because many of these chemicals become more dangerous as they decompose. Opened or partially used containers should not be transported at all. Storage. The storage of chemicals in the salon, spa, or barbershop is also an area where safety and strict processes should be followed to prevent injury and fire. Having designated places to store specific chemicals and never allowing chemicals to set out, even in a dispensing area, can mean the difference between a safe and an unsafe environment for you and your clients. In particular, chemicals should be locked up at all times, and if an adult can get to them, so can a child. All chemicals should be stored and disposed of in their original containers. Even if two chemicals are similar, they should never be haphazardly combined together or stored mixed. When storing chemicals next to each other, it is critical to know how the two would react if they somehow came into contact with each other. For example, an oxidizer such as hydrogen peroxide mixed with a flammable solvent such as acetone results in fire. So placing those types of products next to each other could potentially be dangerous. Caution. Despite being an extremely common chemical in the salon, spa, and barbershop and home, bleach can pose unforeseen safety risks because of its chemical composition and reactivity. Bleach should never be mixed with any cleaning product unless expressly instructed by the manufacturer's label, as even just vinegar and bleach creates chlorine gas. In fact, bleach should always be stored away from other chemicals because of the possibility of harmful gases inadvertently being created. Mixing chemicals can create dangerous gases such as chlorine, nitrogen trichloride, chloramine vapor, and hydrazine. Because these gases can be life-threatening, processes concerning the mixing of chemicals should be clear to everyone who works in a salon, spa, or barbershop, and should never be compromised. Consider these guidelines when mixing or preparing to mix chemicals. The location used for mixing chemicals must be well ventilated and have protective equipment available, including an eye wash bottle. Always read chemical labels thoroughly before mixing. If there are potential reactions listed and you are uncertain if the chemicals should be mixed, do not mix them. For example, bleach has a warning on the label that it should not be mixed with any acids or ammonia products. However, it can be hard to tell which ingredients are acids. When in doubt, do not mix. Use a measuring device such as a measuring cup or spoon and make sure that it is cleaned thoroughly between uses. Always add the chemical to the water, not the other way around, when using concentrated chemicals like disinfectants. When concentrates are mixed and used in a secondary container, such as a spray bottle, That container should be labeled to indicate the product name, ingredients, and any hazards listed by the manufacturer. Disposal. Many of the chemicals that go down the sink drain every day in a salon, spa, or barbershop are dangerous to the environment and create burdens on our wastewater system. Unfortunately, although many products have instructions for disposal of the container, few address disposal of the chemical itself. In many parts of the country, however, programs that recycle the chemical waste from beauty services exist and will likely continue to grow. While most states and countries do not currently regulate the disposal of chemicals in the salon, spa, or barbershop, it is highly likely that such rules will be enacted over the next few years. For this reason, it is important to review your state's rules periodically to see if changes have occurred. Check-in. What are 4 guidelines for properly storing chemicals? Interpret safety data sheets. The OSHA Hazard Communication Standard requires that employees be notified of any chemical in their workplace that could be hazardous. Prior to 2015, the Material Safety Data Sheet, MSDS, was a document used to provide this information to workers and first responders. In 2015, these were replaced by the SDS, Safety Data Sheets. While they contain essentially the same information, there are some significant differences between the two. While both sheets provide valuable safety information about chemicals, the organization and the ease of understanding have been greatly improved in the SDS. All SDS are formatted into 16 categories with 9 accepted pictograms. Remember that because that's probably on the test. 16 categories with 9 accepted pictograms, and are provided for free from the manufacturer of the chemical. Having an SDS available for every chemical used in the salon is a requirement of OSHA. Additionally, it is required that SDSs be immediately available to all employees, so storing them on the computer that only managers can access or keeping them in a locked office is not acceptable. Remember, these sheets are for the use in emergencies, which are often chaotic situations, where every second counts. SDS categories. The categories on the SDS are in a uniform format and order that must be followed by all manufacturers. 1. Identification includes the name of the product and contact information for the manufacturer or distributor. It also contains recommended use and restrictions on use. 2. The hazard or hazards identification. List all hazards associated with the product and include hazard classification, if it's flammable, etc., precautionary statements, and hazard programs. 3. Composition information on ingredients. Identifies the ingredient of the product, including concentrations used in mixtures and when chemicals have been withheld due to a trade secret. 4. First aid measures. Includes short and long-term symptoms and first aid instructions. Firefighting measures is number 5. Lists suitable and unsuitable fire extinguishers, any chemical hazards associated with a fire, and recommended protective equipment or precautions. Health hazards, carcinogens. These are the symbols if you're watching and or if you're just listening. They are safety data sheet hazard pictograms dictated, oh my goodness, by the International Globally Harmonized System of Classification and Labeling of Chemical, GHS. I have the watery eyes again. Number 6, accidental release measures provides instruction for proper cleanup of a spill, protective equipment needed, and emergency measures to follow. Number 7, handling and storage includes guidelines for safe handling and storage of chemicals, including incompatible chemicals. Number 8, Exposure controls personal protection. Provides recommended limits on exposure and methods to reduce exposure, such as personal protective equipment and proper ventilation. Number 9. Physical and chemical properties. Consists of a minimum of 18 properties from color to pH viscosity. Unknown or irrelevant properties for a product must be noted. 10. Stability and reactivity. Provides information on the environmental stability and reaction risks associated with the product. 11. Toxicological information details the risk of exposure, including symptoms like skin irritation and measure of toxicity. Ecological information covers the impact of the chemical on the environment, such as groundwater absorption or danger to plants and animals. 13. Disposal considerations lists all procedures for disposal. 14. Transport information provides guidelines and restrictions for safety transportation. 15. Regulatory information includes any specific safety, health, and environmental regulations. 16. Other information indicates when the SDS was created or last updated. SDS vocabulary. Safety data sheets make use of a wide range of scientific, medical, and specialized vocabulary to describe chemical properties and hazards. While it is well beyond the scope of this book to tackle SDS vocabulary as a whole, it is important to make a distinction between two pairs of related terms. A carcinogen is a substance that causes or is believed to cause cancer. A mutation, on the other hand, is a substance that may cause cancer, but not always. Sorry, I was about to sneeze. Mutations cause an increase in cellular mutations, changes, some of which are harmful. Others have little or no effect on the body's function. Combustible. Material is capable of igniting and burning. Compared to this, flammable material is even easier to ignite. Combustible liquid has a flash point between 100 and 200 degrees Fahrenheit, while flammable liquid has a flash point below 100 degrees. The term inflammable is an older term, meaning flammable, non-flammable signifies something that is not flammable. Check-in. List all the categories found on a safety data sheet. Apply chemistry and chemical safety. Congratulations on completing this chapter. Before you move on, take a moment to think about how these chemistry and chemical safety topics apply to your particular discipline. Discuss with a classmate or study group how chemical reactions will come into play on the job, what processes you will need to follow when transporting and storing products, any special safety measures you may need to take during a service in order to protect yourself and your clients, and so on. Competency progress. How are you doing with chemistry and chemical safety? Check off the Chapter 6 learning objectives below that you feel you have mastered. Leave unchecked those objectives you will need to return to. Explain chemistry and chemical safety. Identify the basics of chemical structure. Explain the differences between solutions, suspensions, and emulsions. Describe potential hydrogen and how the pH scale works. Summarize neutralization and redox reactions. Practice chemical safety. Interpret safety data sheets. Glossary. Acidic solution. A solution that has a pH below 7, which is neutral. Acid-alkali neutralization. When acids are mixed with alkalis in equal proportions, balancing the total pH and forming water, H2O, and a salt. Alkaline solution. A solution that has a pH above 7, which is neutral. Alkalis, also known as bases, compounds that react with acids to form salts. Alcoholamines. Alkaline substances used to neutralize acids or raise the pH of many hair products. Alpha hydroxy acids, abbreviated AHAs, acids derived from plants, mostly fruit, that are often used to exfoliate the skin. Ammonia, colorless gas with a pungent odor that is composed of hydrogen and nitrogen. Onion. An ion with a negative and electrical charge. Atoms, the smallest chemical components often called particles of an element. Structures that make up the element and have the same properties of the element. Carcinogen, a substance that causes or is believed to cause cancer. Cation, an ion with a positive electrical charge. Chemical change, a change in the chemical composition or makeup of a substance. Chemical properties, characteristics that can be determined only by a chemical reaction and a chemical change in the substance. Chemistry, science that deals with the composition, structures, and properties of matter and how matter changes under different conditions. Combustible, material that is capable of igniting and burning. Combustion, rapid oxidation of a substance accompanied by the production of heat and light. Compound molecules, also known as compounds, a chemical combination of two or more atoms of different elements to define mixed properties. Electrons, subatomic particles with a negative charge. Element, the simplest form of chemical matter. An element cannot be broken down into a simpler substance without a loss of identity. Elemental molecule, molecule containing two or more atoms of the same element in finite mixed proportions. Emulsifier, an ingredient that brings two normally incompatible materials together and binds them into a uniform and fairly stable mixture. Emulsion, an unstable physical mixture of two or more immiscible substances that normally will not stay mixed, plus a special ingredient called an emulsifier. Endothermic reaction, chemical reaction that requires the absorption of energy or heat from an external source for the reaction to occur. Exothermic reaction, chemical reaction that releases a significant amount of heat. Flammable, a material that is capable of igniting and burning and easier to ignite than combustible material. Glycerin, sweet, colorless, oily substance used as a solvent and as a moisturizer in skin and body creams. Glycolic acid, an alpha hydroxy acid used in exfoliation and to lower the pH products. Hydrophilic, compatible of combining with or attracting water. It's water loving. Immiscible, liquids that are not capable of being mixed together to form stable solutions. Incompatible, substances that should not be mixed or even stored near each other. Ion, an atom or molecule that carries an electrical charge. Ionization, the separation of an atom or a molecule into positive and negative ions. Lipophilic, having an affinity for or an attraction to fat and oils. Oil loving. Matter, any substance that occupies space and has mass, which is weight. Miscible, liquids that are mutually soluble, meaning that they can be mixed together to form stable solutions. Molecule, a chemical combination of two or more atoms in fixed proportions. Mutagen, a substance that causes an increase in cellular mutations, some of which are harmful, but others which have little or no effect on the body's function. may cause cancer, but not always. Neutrons, subatomic particles with no charge. Oil in water emulsion, abbreviated OW emulsion, oil droplets emulsified in water. Overexposure, prolonged, repeated, or long-term exposure that can cause sensitivity. Oxidation reduction, also known as redox, a chemical reaction in which the oxidizing agent is reduced by losing oxygen and the reducing agent is oxidized by gaining oxygen. Oxidizing agent, a substance that releases oxygen. pH, the abbreviation used for potential hydrogen. pH represents the quality of hydrogen ions. pH scale, a measure of the acidity and alkalinity of substance. The pH scale has a range of 0 to 14, with 7 being neutral. A pH below 7 is an acidic solution. A pH above 7 is an alkaline solution. Physical change, a change in the form or physical properties of a substance without a chemical reaction or the creation of a new substance. Physical mixture, a physical combination of matter in any proportion. Physical properties, characteristics that can be determined without a chemical reaction and that do not cause a chemical charge in the substance. Protons, a subatomic particle with a positive charge. Pure substance, a chemical combination of matter in fixed proportions. Reducing agent, a substance that adds hydrogen to a chemical compound or subtracts oxygen from a chemical compound. Safety data sheets, required by law for all products sold. SDSs include safety information about products compiled by the manufacturer, including hazardous ingredients, safe use and handling procedures, proper disposal guidelines, and precautions to reduce the risk of accidental harm or overexposure. Silicones, special types of oil used in hair conditioners, water-resistant lubricants for the skin, and nail polish dryers. Sodium hydroxide, a very strong alkali used in chemical products and cleaners, commonly known as lye. Solute, the substance that is dissolved in a solution. Solution, a stable uniform mixture of two or more substances. Solvent, the substance that dissolves the solute and makes a solution. Surfactants. Yeah, surfactants. Sorry. A contraction of surface active agents, substances that allow oil and water to mix or emulsify. Suspensions, unstable physical mixtures of dissolved particles in a liquid. I was just out feeding the chickens and my eyes are really watery, so I apologize for my mistakes. Just laugh. It's fun. Thioglycolic acid, a colorless liquid or white crystals with a strong, unpleasant odor that is used in permanent wave solutions. Oh, we all know that smell. Volatile alcohols, alcohols that evaporate easily. Volatile organic compounds, abbreviated VOCs, compounds that contain carbon, organic, and evaporated very easily. Water in oil emulsion, abbreviated WO emulsion. Water droplets emulsified in oil. And I believe that brings us to the end of chapter 6. I will start chapter 7 very soon. We also have some unboxing going on. Please comment, like, share, and subscribe, and I appreciate you watching. In the future, I will also read all of the glossary that is in the back of this book. Not the index, but like starting here on page 301. Do that in the future so you can laugh some more about how I cannot pronounce some of these words, which I don't know why, because normally that's my thing. So anyway, we will continue with this. I appreciate it. Like, share, subscribe, comment, even if it is just a little smiley face. I appreciate it. Thanks. Bye.